This is the internal structure of the earth. Now we will see forces operating on the earth, inside the earth and outside the earth, slowly one by one. Why we need to understand the forces operating on inside the earth and outside the earth? Because what is our intention of this discussion? Geomorphology. Geomorphology is nothing but study of the landforms existing on the earth and processes operating them. Remember, your geomorphology is nothing but landforms and processes. Geomorphology, don't worry that it is a very big terminology or something. No, it is nothing but the landforms and the processes. ఏమేమి ఉన్నాయి భూమి మీద నైసర్గిక స్వరూపాలు అంటాం కదా. ఓకే, డిఫరెంట్ ఏమేమి ఉన్నాయి, వాటి మీద ఎటువంటి ప్రాసెసెస్ ఉన్నాయి. ప్రాసెసెస్ అంటే ఫోర్సెస్ కూడా చదువుతాం. ప్రాసెస్ ఈజ్ క్రియేటెడ్ బై ఫోర్స్ ఓన్లీ. ఓకే, దిస్ ఓన్లీ విల్ సీ. నౌ before going into, do you want to discuss landforms? Because landforms are nothing but majorly mountains, next plateaus, next valleys and basins. Ante kada, this much only, nothing more. Anything more you can see? No. Okay. And again, mountains will be different types. Folded mountains, just for you understanding words I am introducing. Okay, folded mountains, block mountains, see, you know everything. Volcanic. Okay, plateaus, different plateaus will be there, intermountain and everything. Don't worry, just take it as a plateau. Plains, erosional plains, depositional plains will be there. Valleys, rift valleys will be there, normal valleys will be there. Okay, these all are the landforms only we will study at the end of the day on the earth, whatever is there. భూమి మీద ఏమేమి ఉన్నాయి ఈ మాత్రమే చదువుకుంటాం కదా మనం, ఇంతకు మించి ఏం లేదు. సముద్రం దగ్గరికి వచ్చిన వాళ్ళు we will come to that oceans. Okay, next, what all are the processes are there? Earth like this, why it is not there? There are mountains, these are things are there. Why these all things are there? So there are two types of forces acting on it, causing it to create. One is, okay, forces, please, exogenic. Okay, next. Okay, what is this? Okay, why you are calling internal and external? Because some forces are generating inside the earth, some forces are operating from outside the earth. But more than this, I would like to say constructive forces, destructive forces. Because what is our intention? To study the landforms. Soil ni తీసుకెళ్తుంది. ఓకే, రాక్స్ ఉన్నాయి, గాలి ఉంది, స్మాల్ ఇసుక రేణువులు గాలిలో ఉంటే కూడా చిజిలింగ్ ఎఫెక్ట్ ఉంటుంది. చిజిలింగ్ ఎఫెక్ట్ అంటే ఒక బండ కొన్ని ఉంటాయి ఇట్లా షేప్. వై? బికాస్ here at this level you saw some very long rock saying that they will be having cylindrical, but at the bottom they will be more chiseled, more erosion ఉంటాయి. ఎందుకు? గాలిలో నుంచి వచ్చినటువంటి చిన్న చిన్న రేణువులు అవన్నీ కూడా చిజిలింగ్ ఎఫెక్ట్ పనిచేస్తాయి. వాటర్, ఎయిర్, గ్లేషియర్స్, అండర్ గ్రౌండ్ వాటర్ ఆల్సో. యువర్ బొర్రా కేవ్స్, నథింగ్ బట్ అండర్ గ్రౌండ్ వాటర్. Okay, so these all things are removing the landforms already existing on the earth. Okay, these all are the forces endogenetic, that is from inside that some forces are happening. These forces are creating the landforms, whereas outside forces are destructing them, thereby bringing the balance. This balance is called isostasy. We will discuss on this more, just I am introducing the word, that's it. Isostasy. Isostasy is nothing but చాలా ఎత్తైన పర్వతాలు భూమి మీద ఉన్నాయి కింద పడకుండా, Samudramu undi. How it is happening is that the more taller on top of the earth, the depth of that formation is also more. That's why below the continent, when I am saying crust, if this is the mountain, this is the sea, crust will be like this. You are understand? The more above the earth, the more deeper also. It needs to balance. Balance అవ్వాలి కదా, ఎంత పైకి ఉంటుందో అంత లోపలికి ఉంటుంది కాంటినెంటల్ క్రస్ట్ కూడా. అర్త్ పైన ఎంత పెద్దగా ఉంటుందో కింద లోపలికి కూడా అంత లోపలికి వెళ్ళాలి, లేకపోతే ఉండదు. వేరాజ్ ఓషియన్ ఈజ్ డీపర్, ఇట్ నో నీడ్ టు హ్యావ్ ఇన్సైడ్ లాట్ ఆఫ్ డెప్త్. దట్ ఈస్ అ బ్యాలెన్స్. అండ్ వాట్ ఎవర్ ఎరోజనల్ ఫోర్సెస్ ఆర్ హ్యాపెనింగ్, దిస్ ఎవ్రీథింగ్ విల్ కమ్ డౌన్. Depositional material, after some time this height will be like this, this will be like this, okay. This material also will go there, this material will come up, okay. This will not be this much height. How it is happening, that is what we will see. Why it is happening? The interaction between endogenetic constructive forces and exogenetic outside forces is we are going to study. So broadly you told forces are endogenetic, exogenetic, otherwise constructive, destructive. This we will deal it later, we don't bother. And these endogenetic constructive forces also, those forces might be operating for a long period of times. Epirogenic. The word epirogenic means continental building. Longer times they will be operating. Like Himalayas building, they are operating from when? I told geological time scale, Paleocene. What is the period I told? 66 million years ago. They are operating from then. Every day the mountains are growing by 1 centimeter every year. If you see million years, they will grow more also. Now what is the Everest mountain height? 8,848 kilometers or meters? Meters. Okay. So after maybe some 100 million years, its height may not be the same. It will increase more, or it may not be there at all because of the exogenic forces. Which is operating more matters. Okay. Like these endogenetic forces are again two types. One is operating for longer period, operating sudden forces. Okay, these longer forces, longer period forces operating longer period are called epirogenic or continental building forces. Okay, whereas these sudden forces are nothing but, what are the sudden forces? Exactly. See, you say that, you may ask me that you said these are constructive, but earthquakes are not constructive. Not for us. I am speaking from the perspective of earth. నేను భూమి దృక్పథంతో మాట్లాడుతున్నా. earthquakes మనకు destructive, భూమికి కాకపోవచ్చు. volcanoes మనకు destructive, but భూమికి కాదు. So these sudden forces are earthquakes, volcanoes, volcanism. Okay, this is. So how many forces will be there for the earth when you have to study the geomorphology? Two types of forces, constructive, destructive. Destructives are operating from the outside. What all are the agents? Water, running water, air, wind, glaciers, underground water, and even oceanic. This tides kadamma. Tides will not generate that easily erosion. The waves, that whatever the beaches, submergence, emergence, again in sync with the endogenetic forces only they will work. We will discuss that. So we will discuss exogenetic forces latter part of our discussion. Now in endogenetic, those are the constructive. Constructive forces may be operating for the longer period of times, like Himalayans building. And there may be sudden forces, earthquakes, volcanoes. This we will discuss. We will not discuss them separately. One by one we will go, but in tandem only. But how does we know that these all are operating? First of all, these forces are operating. So before that, let us understand. Could you all open your atlas, please? World map, physical geography, world map. How many of you till now were opening atlas as and when you are coming across a new place? If no, it's easy for me, but I want you to open the book and see the places. This page I want you to open, 75 page number. You don't have? Just sit somewhere. Any of you have atlas, doesn't have atlas? Okay. Sekar. సార్ దగ్గర గౌతమ్ సార్ దగ్గర ఏమన్నా అట్లాస్ ఉందేమో అడగ. మీ రోకుందా? హేమంత్ నువ్వు కొంచెం ముందుకు వచ్చే రాదు, అక్కడ అన్ని బుక్స్ ఉండకపోవచ్చు. ఇఫ్ యూ కమ్ ఇట్ ఈస్ ఈజీ ఫర్ యూ టు అండర్స్టాండ్. ఇదే ఏదైనా కానీ తీసుకోండి, ఎనీ అట్లాస్ యూ హ్యావ్ ఆల్సో ఓపెన్ ఇట్ అప్. వరల్డ్ మ్యాప్ ఉంటుంది చూడు, ముందర ఉంటుంది, వెనకాల ఉంటుంది వరల్డ్ మ్యాప్. Each and every page you should be able to remember at the end of the day. ఇదా ఫిజికల్ లేదా? అది కాదు. ఓకే, నౌ హౌ మెనీ కాంటినెంట్స్ ఆర్ దేర్? ఓకే, డోంట్ టెల్ మీ ద నంబర్, జస్ట్ యూ అబ్జర్వ్ సదరన్ అమెరికా అండ్ ఆఫ్రికా ఇన్ ద పిక్చర్. ప్లీజ్ అబ్జర్వ్ సదరన్ అమెరికన్ కాంటినెంట్ and Africa. This is African continent. How is your Southern America? Okay, but it is a bit below, isn't it? Can't I fit it here? I can fit it here, isn't it? Similarly, Northern America and Western Europe. Northern America and Western Europe. See, shapes at least approximately I am drawing. Northern America, Western Europe. If you bring them together also, they will match. That means that Atlantic Ocean, which is separating Northern and Southern America and Europe, Africa, it appears that they both were together earlier, isn't it? This one was observed by Wegener, one scientist named Wegener. So he drew all the, because at that time, see, now you are having map and everything. I am speaking about 1920s, 1910. There were no maps. Just whoever the navigators are there, whatever based on their navigation journey and everything, they used to draw the charts. Based on the charts only they have understood. You might have feeling that Wegener understood this one, even by seeing this I can say that. No, he was not having map like this. The distances they were having, based on the distances he drew such map such a way that they were matching. So he came to a conclusion that all these continents may be now separated by the oceans. ఇప్పుడు ఈ ఖండాలన్నీ కూడా ఓషన్ సపరేట్ అయి ఉన్నాయి, కానీ ఒకప్పుడు అవన్నీ కలిసే ఉన్నాయి. అతనికి ఇంకోటి కూడా తెలిసింది, ఆఫ్రికాలో దొరికేటువంటి ఫాజిల్స్ ఆర్ అవైలబుల్ ఇన్ ద ఆస్ట్రేలియా ఆల్సో, విచ్ వర్ నాట్ అట్ ఆల్ రిలేటెడ్ టు దట్. ఇంకొకటి, ఆఫ్రికాలో ఉన్నటువంటి క్లైమేట్కి కానీ అమెరికాలో ఉన్నటువంటి క్లైమేట్కి కానీ ఉండాల్సినటువంటి ఫాజిల్స్ లేవు ఇప్పుడు అక్కడ. డిఫరెంట్ ఫాజిల్స్ ఉన్నాయి. ఫర్ ఎగ్జాంపుల్ పోలార్ బేర్ ఉంది. పోలార్ బేర్ వేర్ ఇట్ షుడ్ బి ఇన్ పోల్స్, వేర్ కోల్డర్ ప్లేసెస్, బట్ ఇట్ వాజ్ అవైలబుల్ ఇన్ ద savannah also as a fossil. How it was possible? So what he said was, no, all continents were together once upon a time. These were all together, then later separated. He didn't tell how they were moving. You understood? They were together, okay. Now you tell us the reason why they got separated, how they came together in the first place. That's why he called his theory Continental Drift theory. The word, you people told already that, yes. Continental Drift theory proposed by Alfred Wegener. Okay? He didn't tell anything. It is not a theory at all. He told that now whatever the present condition of the continents, once they were together, he called that continent Pangaea. He called that continent Pangaea. One supercontinent he called it. Together like this, everything. Like this he said that it is called Pangaea. In between there was a Tethys Sea. This everything is Pangaea, okay? There was a sea. Though they were together, in between some places it is disconnected and it is Tethys Sea. The continent name is Pangaea. The total this Pangaea was surrounded by Panthalassa. Nobody will ask a single question on that. So don't worry. No need to worry. Panthalassa is an ocean which is surrounded by Pangaea. But the dynamics behind this you need to understand. Okay? What did Wegener came to a conclusion by juxtaposing the different present continents next to each other. Juxtaposing means keeping one next to each other. What he understood? Array, everything is matching. This coast, that coast, everything is matching. Now they must be together once upon a time. He didn't tell the reason why it was. Slowly, he did it in the early part of 19th century. Slowly, scientists started reading more about this. Though scientists rejected it, let us understand the various things. They first came across sea floor spreading concept. Sea floor spreading. Anybody heard? What is sea floor spreading? Suddenly new word came, we will skip. Don't worry. Scientists also didn't come across sea floor spreading word. They came across the fact. What is that fact? Mid-Atlantic Ocean is there. Na? Now just you saw it. North America, South America, okay, Europe, Arctic. In between is Atlantic. Deep oceanic observations made them understand that there is a, like this is Europe, Africa, North America, South America. Okay, here this ocean is the Atlantic Ocean. In this Atlantic Ocean, they have observed that certain area, this side, okay, they have taken the samples on the bottom of the oceans. Samples they have taken, they have started understanding what is this one. One thing they understood, first point is, from this area which is ridge sort of, ridge means oka kondalagundi. ఆ కొండకు అటువైపు ఇటువైపు చూస్తున్నారు. దిస్ ఈజ్ రిడ్జ్. విల్ కమ్ అక్రాస్, we will later discuss what is this ridge exactly, how it formed also. From this ridge, if you move away this side, the age of the rocks is increasing. Okay. Age of the rocks is increasing. That means here if it is like, let us assume for our understanding, this is 100 years. Here rocks. Okay. Here it is 200. Here 1000. Like that it is increasing. Similarly, exactly, mirror image is there this side. Here also increasing. Here 100 years old rock, exactly same, similarly they have found here. Okay. Not only that, second point also they have understood. The magnetic polarity of these rocks is different. Let us assume here rocks having, this is the polarity, that means matching with the, this is the north pole, this is the south pole, positive means north pole, I mean to say magnetic north pole, magnetic south pole. If these rocks are having this polarity, next rocks does not have that polarity. Polarity అంటే ఏం లేదు, ధ్రువాలు, నార్త్ ధ్రువము, దక్షిణ ధ్రువం. ఒక మ్యాగ్నెట్కు నార్త్ సజాత ధ్రువాలు, విజాత ధ్రువాలు, యు నో దిస్ ఆల్ థింగ్స్ నా. ఓకే. నార్త్ పోల్, సౌత్ పోల్, ఈచ్ మ్యాగ్నెట్ విల్ హ్యావ్. సో వెన్ ఎవర్ అర్త్ మెటీరియల్ ఆల్సో ఎవ్రీ టైమ్ విల్ హ్యావ్ ఎ పొలారిటీ. కంపాస్ మనం చూస్తున్నాం చూడండి, కంపాస్ ఎలా చూస్తున్నాం ఎగ్జాక్ట్గా, బికాస్ ద అర్త్ ఈజ్ ఎగ్జిబిటింగ్ ద మ్యాగ్నెటిక్. Based on that only we are telling north is this side, south is this side. Okay. But for some years it is, polarity is different. Exactly they are also observing this side also. May not be similarly alternating also, like this for years. Again polarity reversed. Same, similarly. Are you observing? Exactly at this point, right side, left side, mirror images are coming. And the age of the material, వీటి వయసు ఎంత ఉందో వీటి వయసు అంతే ఉంది. అంటే ఇక్కడ నుంచి లెట్ us assume 1 కిలోమీటర్ దూరంలో 100 ఇయర్స్ ఓల్డ్ రాక్స్ కనుక్కుంటే ఎగ్జాక్ట్లీ 1 కిలోమీటర్ దూరంలో 100 ఇయర్స్ ఓల్డ్ రాక్స్ ఉన్నాయి. సిమిలర్లీ, హౌ ఈజ్ ఇట్ హ్యాపెనింగ్? Then that gave them to the conclusion that here it is spreading. Just reverse లోకి వద్దాం. 100 ఇయర్స్ ముందర ఈ రెండు ఇక్కడే ఉండేటివి కదా, 200 ఇయర్స్ ముందర ఈ రెండు ఇక్కడే ఉండేటివి కదా. ఫ్రమ్ హియర్ ఎవ్రీథింగ్ ఈజ్ జరుగుతున్నాయి. ఫ్రమ్ హియర్ రాక్స్ ఆర్ మూవింగ్ దిస్ సైడ్, ఫ్రమ్ హియర్ రాక్స్ ఆర్ మూవింగ్ దిస్ సైడ్. దట్ ఈస్, దట్ సీ ఫ్లోర్ ఈజ్ స్ప్రెడ్డింగ్, పెద్దదవుతుంది కదా. మరి ఈ రాక్స్ ఎక్కడి నుంచి వచ్చాయి? ఆకాశంలో నుంచి అన్న రావాలి, లేదా ఎవరైనా సృష్టించాలి? నథింగ్. దే ఆర్ కమింగ్ ఫ్రమ్ ఇన్సైడ్ దాట్, isn't it? Okay. Now they understood, they have, now scientists realized that what Wegener was telling true. They are spreading. Here Wegener told that once upon a time rocks were like that only. Wegener told that continents were together. Now they are in the present formation. But here scientists have understood that yes, they are moving. See, for example, you have a for example, this Atlantic Ocean is spreading like this along with this mid oceanic ridge. If it is moving like this, continents are moving apart. If it is closing, they will come together. And earth is a globe. If they were spreading like this, means this side they will come together. Nothing but North America's Alaskan part and Russia's Kuril Islands, ikkada Aleutian Islands, these two together will come. Japan is down, Alaska latitudes lo undadu. Okay. Now you understood. Scientists also accepted that yes, what Wegener told is correct, but nobody was able to tell the still the process why it is happening. Yes, It is spreading, right. Now we accepted the fact that it is spreading. But what all are the forces behind it? Then came, see, nobody proposed plate tectonics theory. It is the collective thought of scientists, geological scientists. Okay. So they said, they proposed everybody plate tectonics theory. Plate tectonics theory is nothing but, they said that, okay, will fit together, may not be exactly, but they will fit together more or less. Here this is the ridge I was speaking. Okay, scientists started observing in these areas how it is happening. Exactly, if this is the mid-oceanic ridge, this side, that side, similar mirror image is there. The age of the rocks is matching. Ikkada enta age undo exactly ikkada ante age undi. For example, this area, whatever is there, this area and this area, both are same rocks are there inside the that means on the sea floor I am telling. Okay, so that is what they were telling. Sea floor spreading, reverse magnetic reversal. Geomagnetism is, it's not constant every time because of flows inside. See, I told you how that convection currents are being generated because of the radioactive material decay. Inside radioactive material చనిపోతుంటుంది decay అంటే those materials will change the form to the different forms. Then heat will be generated. That heat may be today this place, after few years next place. What happens? These convection currents will change their direction based on the correct convective currents direction. Polarity will be there, magnetic polarity. Okay. Now, so after understand, switch off. Okay. So now scientists all together said that, okay, now let us understand what is happening inside it. They try to do it with the help of plate tectonic theory. What is plate tectonics? Because our technology developed, they understood exactly how earth is organized. What I told, crust, top layer we are studying now, crust is there, crust and upper part of the mantle together called true lithosphere. They have understood that there are different, lithosphere is not continuous, it has broken like plates. You are understanding? There is a globe, on that globe different plates are there. These are called lithospheric plates. Okay, and the movement among them, how they are moving, understanding of these movements is nothing but the plate tectonic theory. You know, these plates are creating lot of things in the geomorphology. That means these landforms are created because of those plates only. The maze, there are 50-60 plates. Don't think that there are only one plate or 7 plates because we might have read 7 plates. No, there are 50-60 plates. But if you see, major plates are North American plate, based on the world map I am writing, North American plate, South American plate, this is Eurasian plate, Europe plus Asia, Eurasian plate, Atlantic plate, see below the ocean is also nothing but a lithosphere only. Lithosphere is nothing but crust plus upper mantle. Oceans are, how much depth will be there? Not more than 2-3 kilometers, but they are of 100 kilometers width. Okay. African plate, Australian plate, Pacific plate. How many? 6 or 7? Okay, 7. Apart from this, there are lot of plates. Like here, Latin America is there, this connecting. Here, Cocos plate is there. Here, Nazca plate is there. Here, Indian plate is there. Here, Sunda plate is there. like that hundreds, 50, 60 plates are there. That means the topmost layer, whatever we are calling lithosphere, is not contiguous. It is broke. You can ask why it is not visible then. Lithosphere width is how much? 100 kilometers. You cannot see that. But even when they are break, there is some interactions are happening between the plates whichever is separated. Because of that interaction only some forms are there now. That is what we are going to study. Okay. So, plate tectonic theory is nothing but study of these plates. The lithosphere is nothing but the crust and mantle, upper mantle only, not total mantle. Okay. The study, the crust and the upper mantle together called lithosphere, but now we understood that lithosphere is broken into many plates. The major plates are 7. But there are many, don't think that these only, there are many. Okay. These plates are moving. Okay. Below lithosphere, what is there? Asthenosphere. How is asthenosphere? Plastic. Okay. And viscous, denser than the lithosphere. Not denser than the mantle. Mantle itself is, asthenosphere is on top of the mantle. Okay. Because lighter material జనరల్గా మనకు తేలిక వస్తువులు తేలుతాయి. ఇప్పుడు చెక్క నీళ్ళల్లో వేస్తే ఏమవుద్ది? ఎందుకు? డెన్సిటీ ఆఫ్ ద సింపుల్ ఐరన్ బార్ మునుగుద్ది, అదే రేక్ చేస్తే మునగదు. Density matters, isn't it? That's what crust is or lithosphere is lesser denser. Asthenosphere is more denser. So obviously lesser denser material will float on the much higher denser. That's why these plates, these lithospheric plates which are broken are floating over asthenosphere. Let us assume asthenosphere అనేది ఒక thick liquid. These all are the wooden different plates thrown on this asthenosphere. Okay. Now they will not keep quite like that. They will keep and interact each other. We will come to know what is the forces behind, why they are moving each other also against. Nothing but asthenosphere also moving radioactive decay. The exact force why they are moving nobody knows. There are different theories. I will come to that latter part of discussion. Just take it now that these lithosphere plates are not keeping quite on the asthenosphere. They are very naughty ones. They keep on moving each other. So when they keep on moving, two plates are there. What type of movements can be happen? Either they can come, don't go to scientific so much. We'll come to that words. They can come together, two plates, or they can go away each other, or they can slide. Any other movement can you see? If you have two plates or many plates also, either they can together, separate or slide. This is only. Now, మీ సైంటిఫిక్ భాష అంతా చెప్పండి అబ్బా రాద్దాం. Okay, what I told, they can come together. దగ్గరకు వస్తాయి ఒకదానికొకటి. ఓకే, కన్వర్జెంట్. ఓకే, నెక్స్ట్ మూవింగ్ అవే. నెక్స్ట్ స్లైడింగే పెట్టుకుందాం. ఎందుకు? ఎవరో ట్రాన్స్ఫార్మ్ అన్నారు, దాన్ని ఎట్లా చెప్దాం? యా, దట్ ఈస్ అ బౌండరీ. ఓకే, ఉంది మార్క్. ఓహో, రాయకపోతేనా? ఇక్కడ ఉంది. ఓకే, నౌ లెట్ us see how they work, whatever is happening. Now together I will discuss in a single figure. Okay, fine. Sliding will come to later. Okay, lithospheric plates can be continental plate or can be oceanic plates. Just you saw na North American South American are continental, whereas Atlantic, Pacific are oceanic lithospheric plates. So now I am taking convergent and divergent together. Okay. This is the lithospheric plate. Okay. This is the asthenosphere. I am not discussing because asthenosphere anyway they are moving. I am saying mantle, inside the mantle. Okay, asthenosphere or mantle. This is the mantle part. Okay. Now I need to create the spreading divergent boundary first. Okay. How divergent boundary will be created? Seafloor spreading, I told you there is a ridge, this side and this side it is spreading. How they are coming? Inside the earth. How that inside the earth are coming? Here let us assume magma is created, some chamber, magma chamber. Heat, radioactive material decayed and everything converted to the liquid magma, and when it is converted it has lot of water also with it. Surrounding aquifers it got the water, so steam also created and there is a lot of pressure building inside that because of it is magma. So what happens? It started coming up slowly. Once it started coming up, it tries to lift it up. It may not be burst out exactly. It will try to lift it up, break it slowly, isn't it? Like this. What happens? This will be moving aside. This plate A, now it is B. This side it is moving, this side it is moving. Both are moving. Why it is moving? Inside the mantle, the magma generated is coming up and pushing the lithospheric surface and splitting it apart, breaking it apart, moving away. Now whatever is moving away, okay, let us assume this is nothing but the ocean. Under the ocean this is happening, everything. Okay, under the ocean it is happening, because now whatever we have discussed mid-oceanic ridge, that only I am discussing. Okay, this ocean somewhere, see here Atlantic Atlantic Ocean I have shown you, here Europe is there, here Africa is there. Like that, here some continental crust is there. Continental crust, that is. Okay. When it is spreading, what will happen here? These two will come together. This is the sea plate. It is coming this side. Whether it is coming this side or not, it will become convergent boundary. Okay. When two plates are see, when two plates are going away, no problem, no fighting. When they come together, then the fight will come. Which will dominate whom? Higher density? One will dominate. Dominate means, see, two plates itla vachai. Either they have to go like this, or ఒకటి కిందికి ఒకటి పైకి వెళ్ళాలి. ఇట్లా పైకి వెళ్ళి మాట్లాడదాం మనం. ఇప్పుడు ఏమేం ప్లేట్స్? ఓషియానిక్ ప్లేట్, కాంటినెంటల్ ప్లేట్. ఓకే. నౌ ఓషియానిక్ ప్లేట్ ఈజ్ మేడ్ అప్ ఆఫ్ basalt. Basalt material. Okay. Continental material is nothing but a direct silicate aluminum. This is mafic. Mafic means more denser. Oceanic crust is more denser than the continental crust, and oceanic crust is cooler also, because it is under the water. It is cooler. Cooler means heavier. One heavier plate, one lighter plate. What will happen? Which one will go down? Heavier one will go down. So what will happen? This after interaction will go down. This is called subduction. It is subducted under this because oceanic plate is denser, heavier. Okay. Now, when it is subducted, what is this? Asthenosphere, which is hotter. Magma is there because it is all are hot, viscous, denser, plastic, keep on moving. So, this when it comes down immediately inside this one, it starts melting, isn't it? The bottom portion is nothing but a part of this only, a bit heavier. This portion will be melted and mixed with the asthenosphere, whatever magma is there. But this topper portion is nothing but the sediments coming from this land only, this oceanic plate. Top sediments are coming, na? Water. Inside the sea also, though it is of basaltic, above this is there is a sedimental layer coming from the continental crust only material. So, which is lighter. The moment it gets melted, it is lighter than this material. This heavy material is mixed with the asthenosphere. This lighter material will try to come up, which is volcanic islands, volcanic things will be formed. You are understanding? When oceanic plate and continental plate are coming together, the heavier plate will come down. రెండు ప్లేట్స్ దగ్గరకు వచ్చినప్పుడు ఓషన్ ప్లేట్, కాంటినెంటల్ ప్లేట్ ఏదైతే బరువుగా ఉందో, ఏదైతే డెన్స్గా ఉందో అది ఈ లైటర్ ప్లేట్ కిందికి వస్తుంది. ఇట్లా ఒకసారి వచ్చిన తర్వాత ఈ ఓషియానిక్ ప్లేటు టాప్ పోర్షన్ ఇస్ లైటర్ మెటీరియల్ ఓన్లీ, దానికి డెన్సిటీ ఎక్కువ లేదు, సియాల్ మెటీరియల్ ఓన్లీ. అది లోపలికి యాస్ట్రోస్పియర్లోకి వస్తానే అక్కడంతా ఎట్లుంటుంది, ప్లాస్టిక్గా ఉంటుంది, వేడిగా ఉంటుంది ఆ టెంపరేచర్కి, విచ్ ఈస్ దిస్ ఈజ్ నాట్ దట్. ఇక్కడికి వస్తానే ఇక్కడ బ్రేక్ అయింది, ఇక్కడ బ్రేక్ అయ్యి ఈ కింద పోర్షన్ ఏదైతే ఉందో దట్ ఈజ్ బసాల్టిక్ మెటీరియల్ మిక్స్డ్ విత్ ద ఆస్ట్రోస్పియర్ లేయర్. కానీ ఈ ప్లేట్లో ఉన్నటువంటి టాప్ ఏరియా ఏదైతే ఉందో కొంచెం అప్పర్ పోర్షన్ అంత మెల్ట్ అయిపోయి లైటర్ మెటీరియల్ కాబట్టి బయటికి రావడానికి ట్రై చేస్తుంది. బికాస్ ఆఫ్ విచ్ you are able to get you are getting the volcanic islands on this one. Okay, here divergent boundary ఏమవుతుంది, డైవర్జెంట్ అంటే దగ్గర దూరం వెళ్ళిపోతున్నాయి. ఈ ప్లేట్ ఓషియానిక్ ప్లేటే ఎందుకు వెళ్తున్నాయి, ఇక్కడ ఉన్నటువంటి ఆస్ట్రోస్పియర్లో నుంచి ఉన్నటువంటి మ్యాగ్మా కూడా బికాస్ ఆఫ్ సమ్ రీజన్ ఇట్ ఈస్ ట్రయింగ్ టు కమ్ అప్. ఒకసారి వచ్చిన తర్వాత ఇక్కడ నుంచి మొత్తం స్ప్రెడ్ అవుతుంది. దిస్ ఈజ్ దిస్ సైడ్, దట్ ఈస్ దట్ సైడ్. ఓకే, here when it is moving this way it has to come near to the continent. Okay, so there again this one, now divergent, this one, what did it form, volcanic islands it formed. Those are also nothing but because here it is coming up magma, these volcanic islands are forming. Okay, this is nothing but a magma which comes out will become lava. The lava when it comes extrudes means బయటకు వచ్చిన తర్వాత తొందరగా చల్లబడిపోతుంది. There won't be any space for the crystallization. That is called basalt rock, one type of rock, basalt form అయింది. Whereas in continents it is not exactly coming up. Here for you it is not coming. Basalt is not come. These all are rocks are sedimentary rocks or metamorphic rocks. Even if there are igneous rocks, I will discuss now about rocks only. Even if rocks are there, they were igneous rocks like your dolphin nose, that is nothing but igneous rock. Dolphin nose is the one of the best examples of the igneous rocks. If you see the color of it also very darker. It was earlier inside the earth. The surrounding material whichever is because of the erosion, those all material gone, this one is less erodible, that's why it is appearing as it is. This is the oceanic crust, this is a convergent boundary, here it is a continental crust, continental lithosphere. This plate is moving this side, okay. This is astrosphere. Whatever material here top portion is there is getting melted and becoming volcanic arc. Rocks are made up of what? Minerals. Different minerals will constitute this one. Don't worry, minerals also, what all are there minerals? Just some sort of quartzite is a mineral. Your beach sand, whatever is there, that is the major constituent of the quartz mineral. Feldspar is there, okay. Calcium carbonate is there. Different minerals are there. Those are salts also you can call it. These rocks, every landform is made up of rock. How it behaves is dependent upon the rock. Whether it will get eroded or not will depend on that one. When internal forces are acting, what output will come out, what type of landform will come is dependent on the rocks. There are mainly 3 types of rocks. Okay, చెప్పండి తెలుసు కదా మీకు. Yeah. Igneous rocks, sedimentary, metamorphic. Okay. Igneous rocks. Igneous rocks are the ones? Yes. Inside earth they will be coming lava, magma, and they will be formed. Okay. Igneous rocks are 2 types. One is extrusive, intrusive. Ante these all are because of the volcanic activity they are being formed. Volcanic activity means magma only, the constituent material is magma or lava. If it is because of the magma, those all are called intrusive. Okay. Inside the earth. Idi outside the earth. That means volcanic activity inside the earth means when magma is flowing, if it gets cooled, rock will form. Inside the earth it will get cooled easily, or outside the earth it will cool easily? Outside the earth. So inside the earth it will take lot of time. When lot of time is takes, crystallization, the process of crystallization, rocks are nothing but the minerals. Minerals are arranged in certain manner. When different minerals or same type of minerals brought together, one structure is given, that is nothing but the rock. Okay. If magma, which is a liquid one, is taken lot of time to cool, inside the arrangement of this one, these minerals, that crystallization will take time to form. When more time is there, more crystals will be there, because you have given sufficient time to form crystals inside that. The grains also very much grains, that means yes, coarse grain. Inside grains will be, grains means different like sizes one, molecule sort of ones. Okay. It is grains will be more or coarse grained. Whereas outside, once it comes, lava flows outside, it will not be sufficient time to form the crystals. It cools immediately. Immediate crystals ante ఏదో అనుకోవద్దు. ఇన్సైడ్ మనం రాయిని చూసినప్పుడు గరుకుగా ఉందనుకోండి, ఇట్ టుక్ లాట్ ఆఫ్ టైం. ఇఫ్ ఇట్ ఈస్ నాట్ కోర్స్ అంటే గరుకుగా ఉండడం. ఇఫ్ ఇట్ ఈస్ నాట్, ఇట్ ఈస్ సాఫ్టర్. ఓకే, ఐ విల్ షో యూ సమ్ ఇమేజెస్ ఆల్సో. ఓకే, ఎక్స్ట్రూజివ్. దీస్ ఆర్ ద outside ones. These are fine grained. Okay. Not only that, based on the mineral content also, these will have different this one. If there is a mafic minerals, felsic minerals, there are 2 types of minerals, felsic, mafic. Felsic is nothing but feldspar, silica. Don't worry what is feldspar, don't try to Google geology dictionary, don't read it. Feldspar is one of the minerals, light color minerals, light denser minerals. Felsic minerals are the light colored. మీరు ఎప్పుడైనా గ్రానైట్ కొన్ని లైట్ కలర్లో ఉంటాయి, కొన్ని డార్క్ కలర్లో ఉంటాయి. డార్క్ కలర్లో ఉండేటివి మ్యాఫిక్, మెగ్నీషియం, ఫెర్రిక్. మెగ్నీషియం, ఫెర్రిక్ ఆర్ డార్కర్ కలర్, దట్స్ వై దే ఆర్. వన్ ఈజ్ ఇంట్రూజివ్, ఎక్స్ట్రూజివ్. ఇంట్రూజివ్, ఎక్స్ట్రూజివ్ అంటే బయట వచ్చినాక రాక్ ఫామ్ అయితే చాలా స్మూత్గా ఉంటుంది గ్రెయిన్. భూమి లోపల ఫామ్ అయిపోతే గరుకుగా ఉంటుంది, కొంచెం దొడ్డుగా ఉంటాయి. ఓకే, నెక్స్ట్ రెండో స్టైల్ ఏంటి, రెండో కేటగరైజేషన్ ఏంటి, ఫెల్సిక్ ఆర్ మ్యాఫిక్. ఫెల్సిక్ అంటే చూడంగానే చెప్పచ్చు లైట్ కలర్లో ఉంటాయి, మ్యాఫిక్ అంటే డార్క్ కలర్లో ఉంటాయి, ఇన్ బిట్వీన్లో కూడా ఉంటాయి. ఇప్పుడు మీరే చెప్పండి, ఇది మీ డాల్ఫిన్ నోస్ ఉంది కదా, వాట్ ఈస్ ద రాక్ దట్? ఈజ్ ఇట్ డార్కర్ ఆర్ లైటర్? Darker, isn't it? You might have some hills which are lighter color rocks also. Those all are the granite rocks only. We have in South India, Eastern Ghats are nothing but granitic rocks. We don't have limestones or anything here. Okay, this is igneous rocks. Sedimentary rocks are nothing but rocks formed based on the sediments. How the sediments will happen? Sediments, like river erosion will take place. This igneous rocks, maybe metamorphic rocks, broke down, some small particles came and everything came and compacted together. Pressure is applied, may not be temperature, they are not metamorphic, but because of the compaction and everything they will become rock style. Those all are sedimentary. If those all are those sedimentary rocks formed because of the precipitations, chemical precipitation like limestone, calcium carbonate minerals came together and formed rock, that is limestone. Or organically sediments, organic sediments, best example is coal. Nothing but these trees and everything went inside and formed. But coal can be metamorphic rock. Actually, they came out of sedimentation process only. Okay, metamorphic we already discussed. When pressure and heat both are applied, one form will change to another form. The best example is marble. Our marble is nothing but a metamorphic. From where it came? Limestone. Limestone will give you the marble. The best example to understand now, if you see the limestone is not sunnaprai and sunnaprai battilala chesedi kaadu. Limestone is really like mined limestone is a bit stronger one. If you see that mined limestone and marble, you will understand the difference. We will see that also. Okay, these are the different. These rocks are not like today igneous rock may not be in the same form, or standalone igneous rock may not be there. It may be sedimentary formation also, it may be metamorphized also. So these rocks keep on changing their form. One rock will convert to another rock. This is called rock cycle. This rock cycle is the one which is the main thing for creation of landforms also. Rocks are the constituent materials for any landform. You keep on changing that structure. See, this igneous rocks today may become metamorphic. Metamorphic may become sedimentary. But at the end of the day, whatever is the one more erodible, they will go away. Sedimentary rocks are more erodible, they will go. But metamorphic and igneous rocks are not at all. Okay, now we will see just a couple of rocks, you will understand. This is a limestone rock actually. You are seeing this is a limestone. Okay, is it clear? Limestone rock. Now you will see the marble. Which one is stronger you feel? By seeing itself you can say this is more stronger. Metamorphic is more stronger than the sandstone. Now I will show you the metamorphism exactly more than this. This is the shale rock you are seeing here. Okay, this metamorphism of shale rock will result into slate rock. Seeing the difference? That is more fragile. It is more compact. This slate rock, further metamorphism will lead to schist. This is more stronger than this one. Okay. Similarly, felsic and mafic also I will show you. Rock, and it is a extrusive rock. That means it formed outside the earth, not inside the earth. You see the grain structure? It is a softer. Now I will show a counterpart of felsic, but which formed inside the earth. Nothing but a granite. Difference you are able to see, that is very smoother. It is not. Now mafic I will show you. That means mafic means more darker. This is a basalt rock. మీకు అంటే స్మూత్గా కనిపిస్తుంది అట్లా. ఓకే. Now I will show you, this is extrusive rock. Mafic, you saw the difference between rhyolite, which is lighter color. This is mafic rock, which is a darker color. Rhyolite is extrusive, basalt is also extrusive. Now for basalt, if it forms into same mafic mineral, if inside the earth it forms, how it appears? You saw the grain structure? Basalt is a very smoother, but this is not. Okay? Inside the earth, if it forms, it takes this one. Your question was, why basalt?
Why basalt is producing motion plus why not in continental?
Because continental crust came outside. Continental crust is nothing but either sedimentary rocks or metamorphic rocks. Okay? Basalt is, ocean crust is inside the water. The moment magma comes, it cools immediately, isn't it? It will not be having any time to form crystallization. Basalt will. Whereas continental, remaining everything, these all things, whatever the happening, either it should be eroded or sedimentation will take place, isn't it? That's why there is a lighter material, Cr. Here it is a denser material, basalt. That is the difference. Okay? This is the different rocks. Come together. We discussed now spreading away one oceanic plate, coming together, continental plates come together, what will happen? But if they have to come together means, first there should be ocean in between. At the end of the day, water will be there. Let us assume this continental plate originally, here everything water is there. Okay? They started moving together. When your water is there, the sedimentation will take place. Here lot of sediments will be there, isn't it? The rivers, whatever flowing from this continental plate will deposit sediments inside the ocean floor, one or other way. Okay? These two continental plates are coming together. When these two continental plates are coming together, these sediments will be pressed together. Okay? So when they came near, these sediments will pile up, but these continental plates are very strong. They will push them such a way that pressure and heat both will be applied, because the sediments material will not be in the loose form. They were compacted. For million years they were formed. Rocks were formed. When the pressure and temperature is applied, these will be metamorphism also will take place. But more than that, they will be the more near they will come, the more heighter they will come. What is happening? This material, when two hard blocks are there, in between some relatively soft block is there, you bring together, they will be crumpled. Folds will form. Okay? These folds are nothing but your mountains. Folding. You are understanding? Okay? Now, at the same time, when it may not be necessary exactly folds will happen. If more pressure is there or base, because the material is different material, here they may break also. Okay? This block, together came. Okay? Here material everything formed. Let us assume now fold is also formed, mountain form. More pressure is applied now, this side, this side. This will create a fault here also. It will break. When you push more, the rocks in these lines will break because of the force. But at one time they are creating foldings, at one time they are creating faults. Why like this? Simple example. Simple. You know difference between elasticity and plasticity? Our rubber undi kada. Elastic. Elastic is the one which will stretch. Once you leave the force, come to its original form. The original form is not disturbed in elastic. Just it will move as per the force. In the plastic, if you bend anything, it will be like that only. For example, small aluminum rod, if I bend it, once I remove the force, shape will be like that. You understand? That is a plasticity. Brittle, if I break it, it will not break immediately, it will not bend anything. It will see till what time it will can bear it. The moment my force is more than that capacity to withstand, it will break. That is the brittle. So, a material, when from elastic form, it completely comes to the brittle form, it will break. If material is plastic, it will not break unless otherwise there is a very tear and wear is there. You observe? If material is plastic, mountains are created. If material is brittle, it will break the thing and faults are created. Either when they are coming together or moving away, both ways. Okay? You understood when folding happens, when faulting happens. Folding is nothing but when two blocks are coming together and material is plastic, then that will be wavy like form will, wavy like structures will be created. Those are like this. Okay? Here different rock layers will be there, isn't it? In this, these parts are called, crust, yes. One more thing, anticlines. Anticlines. Okay? These are synclines. So, you might be imagining these all are the hills, these all are the valleys. It may not be true. Thank you. It may not be true also. This also can be hill. If everything is eroded, this is this much. If this is my ground layer, okay, if everything is eroded, this can act as a hill. But inside the bedding plane will be, rock plane will be. You just Google syncline mountains, you will get that structure. Okay.